Now we are going to discuss further properties on a case where the graph have multiple zeros. Now the summary of the main idea that we are going to discuss is mentioned here. So you can see that this is the graph of this function and this is the graph of this function, okay? And you can see now in this case -3, okay, -3 has a odd multiplicity and +3 has an even multiplicity, okay? And here this value has a odd multiplicity, and also this value too has a odd multiplicity, okay? So the difference is at a zero of even multiplicity the graph does not cross the x-axis. So you can see here the graph did not cross the x-axis and the multiplicity is even. And when the multiplicity is odd, the graph will definitely cross the x-axis. So that's a very nice property possessed by the graph according to the multiplicities. And also the third point, when the multiplicity value increases, the flatness of the graph at the zero will increases. Let's do a problem on that property. So here you have a graph of a sixth degree polynomial, okay? So the degree of the polynomial is 6 with leading coefficient 1. So the highest degree term has 1 as the coefficient. All zeros are integers. So it says all zeros in the polynomial are integers. That means you can apply the complete factored form, right? Because remember, there are some polynomials which does not have real zeros or real roots, but in this case they have given that all zeros should be integers. And another information that we can extract out is, so we have roots in the real number sets, so we can use the factored form, the completed factor form. And it asks to write fx in complete factored form, which is this one, okay? So you should have a sixth degree polynomial and zeros are real zeros and also they are integers. So the complete factor format will be something like this with some repeated zeros, okay? Because the graph intersect the x-axis only 3 times, okay? So let's see how we should proceed. Now you can see that by looking at the graph, the zeros of f are -2, 0 and 4, because those are the points where the graph intersect the x-axis. Also, since they have given that the zeros are integers, we know for sure the integer in between these two numbers is equal to 2, and the integer in between these two numbers is 0, and here it should be 4, okay? So yeah, otherwise we might think that the 0 in here can be a different number other than -2, okay? But here it cannot be because the 0 should be integers. Okay, so Now here it says the graph crosses the x-axis at -2 and +4. So at these 2 points the graph crosses the x-axis. Now also, since these are the only roots that this function has, okay, and the function is a 6th degree polynomial, okay, with the leading coefficient 1. So we should have something like this: 1 times x to the power 6 plus some coefficient, let's name it x to the power 5, x to the power 4, likewise up to another constant, right? And these can also be equal to 0, right? These coefficients can be 0 as long as this is not, this coefficient is equal to 1. Okay, so we have the polynomial, and since these are the only roots that it has, we should be able to write it as x minus 2, which is x plus 2, x minus 0, x minus 4. But if you just multiply these together, then the coefficient in the right hand, the highest power in the right hand side will be equal to 3, right? But here it is 6. So we should definitely have some powers for these factors, right? Or in other words, there should definitely be some sort of a multiplicity, okay? And now we can see that the graph crosses the x-axis at -2 as well as at 4. And remember, if it crosses the x-axis, the multiplicity should be odd. Okay, if the graph crosses the x-axis, then the multiplicity should be an odd multiplicity. And keep in mind, 1 is also an odd number. Okay, right. Also, the graph of f levels off more at 4 than at -2. So the multiplicities at these 2 points should be different, and the multiplicity at this point should be greater than this one because it's more leveled off. Okay, right. So 4 should have a higher multiplicity than -2, right? At 0, the graph of f does not cross the x-axis, hence it should have an even multiplicity. Okay, so at 0 it should be even, and in these two it should be an odd multiplicity, and this multiplicity should be greater than this one. Okay, right. Then we can see that to make fx a 6th degree polynomial, okay, that's also a must. Okay, so the multiplication or the product of these terms along with its corresponding multiplicities should give a 6th degree polynomial, right? And we know that this should have an odd multiplicity, and this should have an odd multiplicity greater than this one, and this should have an even multiplicity. Okay, so the smallest numbers that these can have is this with 2, this with 1, and this with 3, right? So that itself will give now this will give a 1st degree polynomial, this will be a 2nd degree polynomial, and here you will have an x cube when you expand this term. So here you have cube plus 2, 5 plus 1, 6. So this itself will give you 6 as the answer, which should be a must, right? remember, in the complete factored form, we saw that there should be n number of zeros when the multiplicities are counted and written like this. So if you go along with this format, then what we have here is one of these and two of these and three of these, right? So if you list down in this format, what you have is -2, comma 0, comma 0, comma 4, 4, 4, right? So altogether you have 6 terms, okay? And if you are going to write it in this way, what you will get will be x plus 2, x minus 0, x minus 0, x minus 4, x minus 4, and another x minus 4, okay? So you can kind of simplify it and write it like this. You can combine these two terms and you can combine these three terms and form this product instead, okay? But if it was another different combination, okay, if it was another different combination, say if this was equal to you cannot have 0 because you already have like there must be a place where it intersects, so definitely it should be greater than or equal to 1. And since it is odd, and if we are not choosing 1, the next smallest possible one will be 3, and let's keep this as 2 itself, and here it should be greater than 3, which is 5, right? And this combination, that is 3, 2 and 5, addition of these numbers will not give 6, so that cannot be true, right? Because in the first place they have given that the polynomial we are dealing with is a 6th degree polynomial. So likewise, none of the other combinations will give 6 when you add up all the multiplicities. So it must be this combination, and our polynomial is equal to this one, okay? You can even multiply all these brackets and find the expanded equation for the polynomial.